Liquid spring. So it's a patented suspension system utilizing compressible fluid as the spring medium. So we use silicone oil. Silicone has a 6% compressibility. That is the spring that we're actually riding on, is that compressible liquid. Obviously, it replaces the conventional vehicle springs and shock absorbers with a strut that performs as a spring and damper function and utilizes electronic control systems. So yeah, as we talked about, the strut is both the spring and the damper all in one, utilizing that secondary volume to get that spring rate change. Computer is going to change that for us here. So it provides significant improvement in ride handling, stability, safety versus the existing traditional springs. So again, you know, leaf springs on there, they just don't do a lot for you. They're going to hold the truck up, but they don't do a lot of stuff in body roll, you know, stability, and load leveling, where liquid spring has all of those functions. Additionally, it maintains a consistent ride height and adjusts for that load change. Okay. So the system automatically and instantaneously varies the spring stiffness and the damping seamlessly to optimize the suspension performance for the vehicle and the road conditions without driver intervention. So we're looking at speed, steering, brakes, high control, and accelerometers. That's what we're getting from that vehicle and all the data that's coming into the computer. That computer then tells the system to stiffen up, soften up, or do something in between. That's what the rate valves are doing all the time. So it's going to loop itself 1,000 times a second. It's going to monitor all those inputs, and then within 40 milliseconds, it can change that spring rate. So that's how we get that stability with a soft ride. So this is really what we're talking about. Our strut is obviously our load carrying capacity coupled with the secondary volume and that rate valve. So when the rate valve is open, that strut gets to compress all of the fluid. That's the soft spring rate. When the rate valve closes, it takes 80% of that fluid away from the strut. That's our high spring rate. So we can open, close, or we can pulse width modulate in between to give us a spring stiffness somewhere in between that. Okay? We're just going to go through some components real quick. You guys know all this stuff, but we're just going to run through it real quick. Major components, it is a 5-link structural suspension, you know, heavy-duty control arms, track bar, lower control arm, upper control arm, and then the struts in there. Okay. Major components as we go through it. Strut, again, that's our spring and our damper all in one element. Next. Secondary volume, this is what we're talking about. This is where we get that spring rate change from. So the dash 4 hose, that's going to go to our pump. The dash 10 hose goes to the strut. The rate valve, this is when we close that off, that strut only gets that little bit of fluid right there, and the fluid is in the strut to compress. That's the high spring rate. When that's open, it gets to ride on all of this fluid. That's that soft spring rate. Power module. Power module, the main reason for him is for load leveling. We're going to add and subtract fluid from our reservoir to go into that secondary volume and struts to carry that extra load. So as we add weight into it, it's going to push a little more fluid and keep that vehicle level. And then if we take the gurneys out and stuff, we're going to basically set that thing back down. We took that load off, so we're going to squat him back down. It's also used for our back door triggers. So when we open up the back doors, we can lower that down, get the gurneys in and out, close the doors, bring it back up. So that's mainly used just for moving that vehicle up and down in load leveling. It's not part of that dynamic spring rate change. That's all done through the rate valve. Obviously, our pickup tube, we'll get into more detail about him. Next. ECU. This is a 2-connector header. This is our older computer systems. The newer computer systems, we're going to have 6 connectors on them now. You may have seen them. We'll take a look at the ambulance out there and see what you got on there. But there is another generation, Gen 6, that has come out. So that started about 1.5 years ago. And these are really becoming obsolete. The chips They just weren't available anymore, so we had to rebuild the computer with new chips that are available. So that was about 1.5 years ago is when we released that. Okay. Driver interface. Driver interface, this is really just your control to the system. A lot of stuff on here, on-off button. If we're going to do maintenance on the vehicle, just turn the system off. You know, if you raise it up with just a 2-post, legs are hanging and it's trying to dump that excess height off of it, and legs are dangling. It just can't get there and it'll error out. You get a red warning light with an associated green light saying, hey, I dumped more than 3 minutes and I've got a fault. So we have fault codes. The amber lights, that's our steering sensing. So as we turn 10 degrees left or right of center, those amber lights will go off and then they come back on as you're towards 0 center. So that's just an indicator of your steering sensing working. Ride mode, comfort, normal, and sport mode. Like we talked about, that rate valve is going to respond less aggressive or more aggressive between comfort and sport. So we're not saying comfort is soft and sport is firm. It's just how aggressive that rate valve is going to respond to those steering, speed, and wind events. Height side, normal ride height. This is where we're going to drive the vehicle at highway speeds. You can have it in low or high position for low speeds. Less than 10 miles an hour, you can raise it or lower it. Or 15 miles an hour, it automatically reverts back to normal ride height. So it will not allow us to run it at high speed in the low positions. So that's one of the checks that we can do coming out of the bays. So we're doing maintenance, put it in low position, drive away, hit 15 miles an hour, it automatically reverts up. That tells us we have speed signal. Speed signal is one of those things, unless you have an oscilloscope, you can't see that. It's a pulse rate that comes out of the system. It's a square wave pulse rate. So it's not like we're getting 12 volts to check that, like a brake signal is. We can check that separately. If we have just a rear suspension, we've only got 3 heights. You got low, normal, and high, but you'll see it transition to the mid-low or the mid-high as it's going up and down. Those are just transitional. If you have a 4-corner system, front and rear, the mid-low becomes tail down, mid-high is tail up, and then high is all up, low is all down. So it just depends if you got a 2-corner system or a 4-corner system, how these lights respond for you. Hydraulic schematic, pretty straightforward. There's not a lot to it. We're coming from the power module, and we're going to go from like our dash 4 hoses for the rears, come out to the back side of the volume. Volume, just a big steel tube, and the rate valve, then a big dash 10 hose to the strut. That's all we have on hydraulic lines for the rear. The front, we have a little jumper hose that goes to a secondary block, and then that block is going to have its hose, same way, dash 4 hose to the volume, volume in, dash 10 hose up to the front struts. Electrical, it looks like a big spaghetti mess, but if we break it down, it's not too tough. We start off with what we call the dash harness. So underneath the dash, this is where we connect to the vehicle. We're going to pick up things like a ground, speed signal, brake signal, 12-volt positive when you apply the brake, constant battery. We no longer use park signal, we do virtual park, but ignition signal, 12 volts on when we ignition comes on. And then the CAN bus, this is just for us. If we come out, we can plug in, we can actually see what the system's doing through our computer, through the CAN bus. And then you got one little connector that hooks up your driver interface. So that's all like under the dash. And then it goes back out into the main harness to the ECU. If we look at a different branch, one branch that comes off, this is a main harness that goes back to the back of the vehicle. You've got rate valves, left and right rate valves, and left and right height valves, or height sensors. Height sensors, 5-volt reference, 0.5 to 4.5 volt feedback back to the system in a ground wire. So typical sensor in most vehicle applications. The rate valves, those are 12 volt activated. Give us 12 volts, the valves close, 12 volts comes off, there's solenoids. So solenoids, we're going to use 12 volts, height sensors, steering sensor. It's a sensor. We're going to use 5 volt reference coming in and get that feedback through that range of motion. This is the door signals. If we have a 4-corner system, we have the ability to kneel all 4 with one of the trigger wires, or the other trigger wire is just a rear door only. So we got a ground wire that's in the middle. In case you don't have a good ground on the vehicle, we give you a ground. You can run it out to a switch. Through that switch, bring the ground back into our system, and that will tell it to kneel. Whether it's a side door that you want to trigger all 4 down, or the back door you want to trigger just the tail down. So as long as we have that ground applied, the system will hold it down there. As soon as you break that ground away, it's going to come back up. This is from the normal ride height position on the driver interface. So if you've actually put the driver interface in low position, it will ignore these signals. You've done that for a reason from the front, and this will not override that. The front driver interface overrides this. The big 80 amp fuse. 80 amp fuse, that's going to drive and power all of our electronic or electric components. The electric components, I'm saying motor, the solenoids, all of those components are going to be powered by this 80 amp. These little guys up here, which is the ignition and the battery, those are like 5 amp fuses. That's what's going to actually wake up the computer and have the computer communicate with stuff. Low voltage, where this big 80 amp brings it in here, that's going to go to our, basically all of our FETs, and the FETs are going to drive all the solenoids. Turn the motor on, turn the isolation valves, open them up, or the rate valves. All that stuff is done through this 80 amp. So this is one thing that we sample. One of the faults is, low voltage. We're sampling this 80 amp voltage right here. If that fuse blows, we'll get that low voltage warning light. If these guys blow a fuse up here, ignition, it won't come on. It won't wake up. The driver interface won't light up. If the battery if that one's blown, the system won't wake up at all. So everything's dead, won't do anything. But if you get a signal here, that means this guy here is saying, hey, we've lost voltage, or the battery's below 9 volts. Below 9 volts. Swinging over here, steering sensor. The steering sensor is the same as the height sensors. It's just a different linkage arm in travel, but it's the same sensor, same exact one. 5 volt reference, and then we're looking at 0.5 to 4.5 volt return back to us. So something to note, the chip that's on the computer is, it's one chip that provides all that 5 volt reference out of the computer. Then it's branched to 5 different directions for your front 2 sensors, your rear 2 sensors, and your steering sensor. So potentially you could have an issue with, a sensor up here that's low voltage, but if the rest of them are good, we know it's not the chip that's causing the problem. We know it's something in the wiring or the sensor itself is defective. And if we start to see multiple of them getting pulled down, we start disconnecting sensors to see if one of them's grounding or shorting that's causing the whole system to pull down. The fronts have the same as the rear, front left, right, height sensors, and then there are isolation valves. So that's another branch that plugs in here that powers that front. So the main harness is set up for a rear only, but you can plug in a front. That's how we get front electrical. Electrical schematics, so this really goes back to the manuals. The manuals themselves basically has a full schematic of the electrical system, and it's going to tell us what color wire, the terminal end, what to expect for a voltage, and what the operation of that wire is for. So schematics are a good tool to use if we're trying to troubleshoot stuff. Obviously fuses in there. So service and maintenance, one of the things to know, everything that we do is driven off the serial number tag. The bill of materials, the software, what version, rev level that suspension is done in, built in, that's tied to that serial number. So when we're ordering parts, always, always, always reference that serial number. That way we get the right parts. Say for some reason there was a change, they did a bolt change or a bracket clearance issue, all of those things are brought into play based off that serial number. Depressurization of the system. Obviously, we're working with a system that's going to have anywhere from, it could be 1,500 to 3,500 to 4,000 PSI on that system when it's sitting there. So the system doesn't have to be turned on. It's holding that pressure in that, on those lines all the time. So those are big pressures, and it's not something you want to be just sticking your hand by to check for a leak. Just don't do that. Depressurization, there's a couple ways to do it. We'll go through a method outside, but typically we'll just take it to the low position when it's all the way down to low, and then we hold the down button, and then we'll start to hear audibly what the isolation valves will start clicking when there's no pressure on them. We can hear those. Again, if there's a problem with the rate valve or isolation valves, you can't get that pressure out, that volume has brake bleeder nipples on each end. That's our backup to make sure that we get that pressure off. System bleeding and fluid levels. So the power module has a little tape now on there that says minimum, maximum, and that's what's going to tell us what our fluid level needs to be. Again, that fluid is clear in color. Sometimes it's hard to see. You can't just put a flashlight straight onto it. You got to shadow it from the back side. Shadow that thing from the back side, you'll see where that fluid level is in the tank. Again, if we break open these lines, if you're going to get something from the shop, the struts, they're full of fluid. They've already been pressure tested before they leave the shop. Volumes with hoses on there, those are full of fluid. They've already been pressure tested, and they're full of fluid. So if we're mindful of how we're disconnecting the system, and we're not just leaving the hoses lay down low and you're dumping all the fluid out of this, there's not a lot of bleeding to do. But if that happens, they tore a line off and they've dumped all the fluid out of the volumes, open up these bleeders before you turn the system on, and that allows the fluid to come in, and as that fluid fills up, the air is coming out, and then you close them when you start to see fluid. That's the best way to bleed this out of these things. Because really, when you get 3,000 PSI on this system, there's not an air bubble anymore. That air is entrained in the fluid. You don't have a big air bubble, so you crack this thing open, you're not going to get that air bubble like you would on brake system. Our pressures are just much, much higher. So then it has to bleed out through the reservoir. Raise it up and down a few times and let it sit. It'll degas, air will come out of the fluid, and it'll go through the filter. And then do it a few more times. And it takes some time to get all that air out of the system that way. You got a daily check is really, when I do more stuff like an operational training for the operators, it's start it up in the morning, and you're going to look at your driver interface. You should have 2 green, 4 amber, and no red. So what did I say? I had 1 green light in the ride mode. I have 1 green light in ride height. I've got 4 amber lights, turn right, left, they go out, and I don't have a warning light. Operational, it's good, no fluid on the floor. Ready to roll. Good system. But that's really what we're doing, daily check, just looking at the lights, make sure the lights are working, and you don't have a warning light. After that, so the first 1,000 miles, drive it for 1,000 miles, we recommend that it gets retorqued, the suspension. Again, we're not a Ford, Chevy, Ram facility where they've got these torque machines for every bolt. We got guys coming in on a Friday or a Monday after a good weekend, and they may miss a bolt here or there, torquing it up. So that's really a good check. Just make sure that the manufacturers put them on there correctly, get them out here. There is a little bit of stretch in the, say, U-bolts. You'll get some stretch out of those U-bolts. It doesn't hurt to get those things torqued. So 1,000 miles, retorque the suspension. Enough on that. 25,000 miles, that's kind of the routine visual inspection. Again, we're looking at fasteners, we're looking at the hoses, fluid level. So I kind of tell everybody, think about it like power steering fluid. You know, if it's not dripping, it's not wet, it's probably fine, but give it a quick look at the hoses. And being mechanics, we know if you see like a rust bleed line, that's a fastener that's working and that's loose, that's causing that rust line. So double check and tighten those up. In the manuals, we have our service manual that gives you the parts breakdown. Parts breakdown correlates to a number, part number, and what that part is. You might call it something, I'm going to call it something different, and by the time we get the part order, it's the wrong part. Let's just find the right part. We'll call it out by part number that we identify. That way we know exactly what we're getting. Again, back to that torque spec. So the manuals, everything that we have for the manuals, it gives you that component, tells you the hardware. So it's a 5/8 fastener, and you're going to torque it to 172 to 210 foot-pounds. Dry torque. Some torques are wet torques. The U-bolts. We do fine thread top lock nuts, and those ones we put anti-seize on them, so it actually pulls those down smooth and evenly. So those are wet torques, and those are torqued to that wet value. If you put anti-seize on these bolts and try to pull 210, then you're going to be pulling more like 240, and you're going to snap the bolt. We're expecting that X amount of friction to pull on that bolt in a dry torque situation. We'll reduce that torque if we put lubricant on them. Okay, just be mindful of that. Troubleshooting. So if we have a warning light, the correlating driver interface will tell us it's going to be like a warning plus ride. So ride of normal, and that says pump motor runs in excess of 3 minutes. So I set a ride height of high, the motor ran for 3 minutes, it didn't achieve that height, and it's going to give us that warning. So red light will come on, and the ride mode of normal would come on. But again, all of the fault codes are here, and then some corrective action. Service manuals, support, we can go to Liquid Spring, but the manuals will be on the website. Obviously, liquidspring.com, that's the website to go to. Parts and service guys, if you want to write this down, I'll give you the number, you probably have it, but it's 765-474-7816, extension number 1. Email service@liquidspring.com. So power module, I want to get more in depth on this guy here. So this is really our newer power module. Obviously the reservoir, your pickup, screen, tube, the motor, the pump is inside the fluid. That's where we hold him. Right now, this is a change. We used to have, this was blocked off and this was a filter on this end, but we were getting moisture from very humid areas. So we go down south, we're getting moisture from just doing, up, downs, up, downs, up, downs all day long, and we were pooling water at the bottom, and we were sucking that water up. So that's why we now have the desiccant breather back here. That's to prevent that moisture from getting into the reservoir. So the little air line goes in here, plugs in there, and then that desiccant filter, that just unthreads whenever it changes to, I think pink is when you change it out. The old power module block, the main block, that's where the pump bolts onto and the motor bolts onto the face of it. This block used to be a 3-piece block, and then there was we'll call it modules of blocks, and there was O-rings between them, and we had found that the O-rings or the fasteners started to loosen up in these blocks, and we'd blow the O-rings between them. So we did a lot of work rebuilding this manifold system to house it all in one, to eliminate those failure points. Those are some of the early first 3 to 4 years of Liquid Spring, but some of those things are still running around. So the solid block, this is more modern. AB ports, those are for the front suspension. So if you put a front suspension on, we pop these plugs out, put fittings in up here. That's what powers that forward isolation block for the front system. These are our rear suspensions, and we've gotten to the point now where, yep, they were stamped left, right. Well, that wasn't good enough, so we did a male and a female. That wasn't good enough. So then we started putting color codes, dots on there with hoses with colored bands also. They've gotten to the point where they've changed these fittings so that the hoses would go where they want them to go. ECU, again, there's more header plugs up in the top. So getting more into the block and the isolation valves and the pump. So the motor, obviously that's pretty straightforward. Motor, then off to the motor, we've got our left isolation valve, and then our right isolation valve, and then our left and right pressure relief valves. So the ISO valves, we call them ISOs, they're solenoids. Those are your left and right solenoids to isolate that low pressure fluid from the high pressure fluid that's out in the system. So we're going to open and close these as we fill or dump fluid back into the reservoir. These pressure relief valves, those are set to 4,500 psi, 4,500 psi. The reason we got them up there is we want to protect the hoses. If they go out and they jump that ambulance and they come down and they squat that thing all the way down to the jounce bumpers and that rate valve is closed, we can see a pressure of 10,000 psi. So we're letting fluid squirt back into the reservoir rather than blowing hoses apart. Off to the side, under the motor area, same solenoid, same dump valve, pressure relief valve, but that pressure relief valve is set to 4,000 psi. So the motor in the pump is only going to bring up to 4,000 psi, where these ones are 45. So don't be taking these and putting them over here. Guys, I've seen them do it, say, well, hey, I'm testing stuff. Now they get them confused. Unless you've wrote on them and marked them, for testing purposes, get them back in the right holes. Because that one is a lower pressure and you'll have problems with the system not calibration-wise. It won't calibrate right. But the isolation valves and the dump valve, those are all the same solenoids, same cavity, so those can be moved around. So this is where we start to get into the guts of it. How does this thing really work? We have flow restrictors. So thinking about this, I know it's kind of a hard visual here, but here's those AB ports that were up on the top. That's where we're going to get our front suspension power from. Here's our left and right to the rear. Inside these things, there's flow restrictors here and here, and there's filters inside them. Those little brass cone filters. Back in the day in the old Chevy, you take off the carburetor, fuel line, and they had those little brass. Same thing. These are a 10 micron, and now we're going to they're opening it up to a 20 micron filter. But these filters here, main filter here, but those filters, they can get, plugged up, and you can see some flow restriction. So you can take these guys out, pull the fittings out, and you can spray them off, clean them off, and blow air through them and clean them if there's debris that gets in them. That's a potential. So check valves, there's check valves in the system that's going to obviously, manage the pump is only going to go one way, so you can't push pressure back into the pump and drive everything backwards, okay? So flow restrictors, filters, check valves, and obviously the pump coupler. So the motor has like a shaft, the pump has a tang. Well, they're not actually buttoned together, so there's a coupler that goes in between them. So that's been redesigned many times. So there's a bearing in there that helps protect that. It used to just kind of drive like the old Chevy pumps. So they clipped in for the motors. So system filling. So we're going to put pressure out to the system and we're going to lift that vehicle up. The Motor comes on, pump comes in, so we're sucking fluid in here. Fluid comes into the cavity from this side out of the pump. Now it's going to pressurize this leg. In this leg, we have our main ports here, and then our other ports coming through there. So now we're showing where all of our pressure is coming into all of these different areas. Our pressure relief valves, our dump valves, and our ISOs are back here. So your ISOs here and here, that's what's going to allow the fluid to come out the end. Isolation valves has to come open, otherwise it's blocked right at the ISOs. That's what's preventing it from going out the end. Any questions on that, how that flows? Main cavity goes into the next port over here. It's double bored here, fills this cavity, comes into the ISOs, waiting for the ISOs to open up to allow fluid to come out the fittings to go to the rear. That's its pressure flow. System dumping. So now the fluid's coming back from the struts. We're going to go back through the same fittings to the isolation valves. Now the ISOs have opened up and allowed it to fill back into this cavity. Now that's bored into these areas right through here, and then it shoots right back into the reservoir. So it's flowing right back to the reservoir, okay? And that's where that check valve was. So pump pressure relief system. So we talked about, that pump will build 6,000 PSI. We don't want that, so we have a pressure relief system that's going to allow that to dump off at 4,000 PSI. That's what we're going to regulate him. So his pressure relief valve is over here. So the pump is in here, that same cavity, and then all of a sudden it sees this and it's going to say, okay, we hit that 4,000 PSI, it cracks open and just shoots fluid right back to the reservoir. So one of the things to think about there is if that pressure relief valve or that ISO valve when we're dumping, we'll stay with this right now, pressure relief valve, if it gets any junk in there, that pump will just constantly just cycle. You won't get any flow. It's not going to build pressure. It's just going to free flow right back to the reservoir. So you can hear that motor. When that motor is always more of a high pitch, just a constant hum, it's not building pressure. You can hear that tone. When the thing starts to, bog down, bore down, okay, we're building pressure now. And it's a tone you can hear in these things. But if that thing is just constantly running, either A, we have no fluid, or B, we're cycling that fluid right back to the reservoir. So one of two things can happen. Either that pressure relief valve has some junk in it, or that dump valve can have junk in it, because that dump valve will do the same thing. That dump valve is on that cavity. Pressure relief valve for the systems. So each of those, isolation valves was like here and here. That was right and left isolation valve. What it's doing now is the pressure is coming back from the struts, coming through the fittings, and instead of the isolation valves, which they're holding the fluid, well, now the pressure has gotten too high because they jumped the ambulance. So these pressure relief valves will pop open, and then it goes into their little cavity and then dumps pressure back to the reservoir. So pressure relief valves can dump right back to the reservoir. So let's take a scenario. We've got an ambulance that bleeds off and leans over on one side. Okay? Fluid is captured from the power module to the strut. So how does this thing lean? Something's wrong, right? Where's that fluid? How's that fluid letting that system go down on one side? So either we have a pressure relief valve that's seeping and allowing that fluid to go back, or think about it in the dump mode, you're going to have an isolation valve on that channel, so the right side or left side, and the dump valve has to be bad also. Think about that. When the dump system works, isolations have to open and the dump valve has to open before I can get fluid to go back. So if I've got one that leans over, first thing I'm going to check is these pressure relief valves. Right side to left side, I can switch them. Agreed? They're both the same. It's not that system pressure relief, it's the right side, left sides. Those are the same. If I switch them, and that system then now migrates over to the other side, we know it's a pressure relief valve. That pressure relief valve is bad, it's seeping and allowing fluid to go back. If we do that and it stays on the same side going down, it wasn't a pressure relief valve that's causing the problem, it's an isolation valve. And if I've got an isolation valve leaking, I also have a dump valve leaking. You can fix one, but the other one still has an issue. You've only fixed half the problem. So if you're using that method for troubleshooting, change both isolation valves if you change them, or flip-flop to your pressure relief valves and see if it follows you. That's the fastest way to do it. You can just pop those guys in and out and see if it changes over the other side. Then you just change out one pressure relief valve.